Good morning. I hope you can hear me now. So if you do, please feel free to click on the microphone and speak. Anybody can confirm?
Yes, I can hear you.
Thank you so much. So today we're gonna start chapter 7, and in chapter 7, which is homework, will be 6, and tests. We're gonna talk about testing claims. Now, and there are two types of claims that we're going to target. Not every claim in there, but just two types of claims. Claims about the mean. And notice that when we make a claim about the mean, we make a claim about mean of all. And a claim about a proportion. And we make a claim about a proportion, we make a claim about a proportion of all. So it's P. So either way, we're going to look at those two things, and not today, but we're going to look at those through this chapter. Now, one of the questions in your homework, and in not only one, in many questions in the homework, you have to pay attention in the last part of the question when they ask you to test a claim. And in the last part of the question, they were always asking about what should we do, reject the claim or fail to reject the claim. And sometimes they use the word sample mean, and the claim is never ever been or is going to be about sample mean, but about the population mean. So pay attention to those things, because again, if I want to know about a sample, about few people, I just go and ask them. It is possible to get to 50, 100 people, but it's not possible to get to all of them. So that's the reason why the claim is about something that we cannot get to. Now, and in this case, as in previous chapter, when it comes to the mean, there are two possibilities: sigma known and sigma is unknown. When sigma is known, we're going to use Z for Z critical, and we're going to use Z for Z test. That, like we did the same thing with the previous chapter. Now, when sigma is not known, we're going to use T for T critical, and we're going to use T test. So again, remember those two things, because many students, when they do their homework, they always have this concern. My answer is very close. Now, it must be a rounding problem, and it's not true sometimes. Sometimes not the rounding is the issue, sometimes is the wrong test. Because if you use the Z test in place of the T test or the other way around, the difference should be very small. Okay, so be careful with those two things. Now, for a proportion, we're going to use, for a proportion, we're going to use the Z, again, we're going to use a Z critical as with the mean with sigmas known. It's the same thing. We're going to use a Z critical, and we're going to use, for a proportion, we're going to use a proportion test. So we're going to use proportion test. And we're going to get to that later on in section 7, think 4. But let's stick with those things. So again, since I'm talking about sections, this material here will be covered in section 7.2. This will be in 7.3, and this is in 7.4. So, but before I get to 7.2, 3, and 4, I need to talk about general ideas. Now, like in the justice system, let's go to the justice system for a minute, because in the justice system there is a claim. There is a case, and somebody is accused of a crime. And remember, not every accused is guilty. So what will happen is there are two lawyers. One is a prosecution. The prosecution's goal is to convict. And there is another lawyer is the defense. And the defense is to quit. So, and they try to make statements. One will make a statement about guilt. One will make a statement about innocence. Now, or no guilt, let me correct myself. Same thing in here when we test claims in general, regardless of what you are testing, there will be two statements. We call them hypotheses. So there is a hypothesis, we're going to call that H note, and that is called the null hypothesis. And there is another statement that is called HA, and that is called alternative hypothesis. Now, notice that, like in court, those two statements are what we call in math complements. And another term for complements is opposites. Now, what do you mean by opposites or complements? Now, in this case, let's say one is true, the other will be false. Okay, but we're not going to use the term true or false in this class. We're going to use the term reject, and we're going to use the other term, which is fail to reject. Those are the terms we use. Now, like in court we don't use guilt and innocence. We use guilt and no guilt. That is equivalent. Those two statements are equivalent there. Now, another thing we want to tell you, always we start with this assumption. We assume H note to be true. Like, we're going to start with the assumption always, in good faith, we're going to start assuming that H note is true. Let's go back to the justice system. In the justice system, we always assume that the accused is innocent till proven guilty. Now, how we prove guilt is, again, we start with the assumption of innocence, then we start gathering evidence. And then we start discussing those evidence and trying to prove those evidence to be true and so on till prove guilt. If we fail to prove guilt, then we say the accused is not guilty or not innocent. Same thing in statistics. Somebody will make a claim. Now, what they are making a claim about a product, like a manufacturer is making some batteries or toys or something like that, and they claim that the average lifetime of their battery is, let's say, 50 hours. Now, we cannot just look at them in the face and say you are wrong. We have to go and dig in deep for evidence. So what we do in statistics is we go and we run what we call a survey. So we go and we test some of the products, some of those items produced. Let's say we talk about batteries. We go and at random and we select, let's say, 50 batteries or 100 batteries, and we test them. Now, the sample is going to give us some results. Now, we're going to use the results of the sample to prove or disprove the claim. Now, again, to be more accurate, to disprove the claim or fail to disprove the claim. Okay? So, and this is our goal. So, this is what we're going to start with. This is what we're going to work on. But before we continue, let me see, and again, sometimes it's hard to control this. Let me see how we work with those things. First of all, our goal is like in court, we have to, you cannot just go in front of the judge and say whatever you like. You have to write things down. You have to write your appeal, you write your case, you write whatever it is. So we're going to write two statements. And the two statements we're going to write is, the first one is called H note. The second one is called HA. Now, then we're going to put it like this one. Now, if we're talking about a mean, both statements will be about the mean. Now, if we are, let me go on the other hand in here. Well, if we are talking about a proportion, both H note and HA will be statements about a proportion P and P. Okay, so remember that. Now, if your statement includes equal, less than or equal, or greater than or equal, it goes with H note. So anytime you mention equal, less than equal, greater than or equal, it goes with H note. Anytime you mention the opposite, which is not equal, or greater than, or less than, it goes with HA. Same thing in here. Same thing in here. It's going to be equal, less than or equal, or greater than or equal. Here is going to be not equal, or greater than, or less. Notice that you're not going to have all of them. You're going to have one of those three things. And there is more than one way to say those things. Now, if you look at the PowerPoint for equal, for example, sometimes we say equal, sometimes we say is, sometimes we say the same as, sometimes we say it's not different than. It all means equal. Now, less than or equal, sometimes we say at most. At most is the same as less than or equal. The maximum, less than or equal. No greater than, less than or equal. Now, for greater than or equal, sometimes we say at least. Okay, at least means, let's say if you go to a bar and the sign at the door says you must be at least 21, means 21 or more. So there are many ways to say those things. Now, for the other ones, not equal, sometimes we say just not equal, or sometimes we say different than, or not the same as. It is not equal. Now, for greater than, just sometimes we say greater than, sometimes we say more than, sometimes we say higher than. So there are many ways to say that. The same thing with less than. For less than, sometimes we say less, sometimes we say below, sometimes we say under. So more terms can be used to describe those things. So you have to be very careful. Read the claim. Two things you need to focus on. Read the claim. When you read the claim, look for what we are making the claim about. Is it a mean? Then use the letter mu. It's a proportion, use the letter P. That's the first thing you need to capture. The second thing you need to capture is what are they talking about here in terms of equality or inequality? Did they say equal? Did they say less than equal? Did they say greater than equal? Did they say not equal? Did they say less or more? One of those 6 possibilities is going to be in there for you. Now, the minute you find one, place it where it's supposed to be. So if it has an equal, it goes on top. If it has no equal in it, it goes in the bottom. And other one will be the opposite. Okay. Now, I'm sure many of you are wondering, saying, what is he talking about? So let's take some examples. Here is example 1. What if I'm talking about this? What if somebody makes a claim and say the mean age of whatever it is, let's say the mean age of college students at a certain college is, let's say, 24. Now, automatically, I'm going to go in there and write 2 statements, H note and HA. Both statements will be talking about mean. So it's a mu here and a mu there. In this problem, they mention is 24. Is stands for equal. So the equal goes with the top, doesn't go with the bottom. Now, the minute I know the top is equal, the bottom is going to be the opposite of equal, will be not equal. Because the 2 statements, H note and HA, are opposites. So if one is equal, the other one is not going to be equal. And then what they're talking about, the number 24. So the number 24 will be the same. So as in court, the 2 lawyers will be talking about the same issue. So if we're talking about 24, we're talking about the same number, 24. The only difference in here will be, the top one is going to be equal, the bottom one says an opposite thing, which is not equal. So this is the 2 statements. Now, another thing I need to add in here is the word claim. Now, I want you to talk to me and tell me which one of the 2 statements is the claim. Is it the top one or the bottom one? Any volunteer, press the microphone and speak, please. So this way, I don't forget that I'm teaching right now, and I think I'm by myself.
The top one?
The top one, yes. So this is what we're going to do from now on. Every time you write H note and HA, you put the claim next to the correct statement or the corresponding statement. So the claim is the top one. Later on, we're going to come back and discuss this further, but this is what we have. This is how we translate this claim. Let me give you another one. What if somebody makes a claim? And by the way, sometimes when you read a problem, it says the claim is. Sometimes it says assume is. Sometimes it says think is. So the claim doesn't have to be claim. It says, what if somebody says, I predict that. I predict that the same as I am assuming that, the same as I am claiming that. So the word does, when you read a claim problem, it doesn't always include the word claim. It may include an equivalent word to claim, and it is a claim. So let's say that there is a claim here that the percentage of people we don't know. Let's say the percentage of people who support a certain issue is under, let's say, 50%. Notice that in terms of you know, passing an issue in an election or not, we look at the 50% margin. Okay, so if the issue gets less than 50%, then it's rejected. So somebody claims that listen, hey guys, don't worry about this. This is before the election. Don't worry about this. This issue is not going to pass. The percentage of support for the issue is 1%. So how do we write the claim for this person? So here is H note, and here is HA. Now both statements will be statements about who? Is it a mean or a proportion? So when I ask a question, I'm expecting an answer. So any volunteer?
Proportion.
Proportion. I appreciate that. So we're going to use the letter P for a proportion. Notice that a percentage is a proportion. So in case somebody till now doesn't understand what a proportion is, it's a percentage. So the proportion or the percentage is given in this case. Notice more that it says is. I'm looking for the second magical word, which is under. Is under means less.
Yes.
So, and the less goes with the top or the bottom. Which one you think?
Bottom.
The bottom. So we're going to put less in here. Now, what is the opposite of less? Let me give you, just a second. Just a second. Let's say that I walked into a room and I said, those under the age of 21, go to the left. The left of the students will be what? Under 21. So what's, if under 21 will go to the left, the more than 21 will go to the right. What about the 21? Is he going to go or she going to go with the less or the more?
More.
More. So remember, the opposite of less is greater than or equal. Because if you tell me the opposite of less is more, then what about the equal? The one who is equal, where is going to go? So in this case, because the rule says under, so the under goes in the bottom and greater than or equal goes in the top. And by the way, it says 50% in here, so I'm going to use 50%, which is 0.50. 0.50. So this is, we cannot write the 50% as 50. We have to write it as a decimal. Now let me ask you this. Which one of the two statements is the claim? Is it the top or the bottom?
The bottom.
The bottom, thank you. So I want you to remember that from those two examples that we see on the screen now, like in court, sometimes my lawyer is making the claim, sometimes your lawyer is making the claim. Let's say that we're in court facing each other. So the claim is not restricted to H note. It can be H note or HA. The claim sometimes is H note, sometimes it's HA. It depends on the statement made about the claim. So another thing I want, we need to draw a picture, and the picture we need to draw is really the normal curve. So we're going to put a normal curve in here, and we're going to put a normal curve in there, because this is going to help us in a great deal. So let's look at the problem here. So how do we decide? This is one thing in that we need to pay attention to, which is your claim, your test can be, your claim can be left-sided, right-sided, or two-sided. What do we mean by left-sided, right-sided, two-sided? Always look at HA, only HA, don't look anywhere else, look at HA. Now, if you see less, it means left-sided. We call that in statistics left tail. If it's more, we call that right tail. If it's not equal, we call that two tail. So let's look at the problems that we already discussed. Look at HA in the first problem here. Here on a tail in there, and we call this two-tail problem. Now, look at this problem here at HA, if it's less, less means the left. Again, when somebody tells you less, you point to the left. So this is a left tail. So there is, now in this example, we don't have a right tail, but let's say there is a problem with a greater sign. If it's a greater sign, you just go to the right side and shade it. Okay? So you could have a left tail, right tail, or two tail. Again, what I'm trying to do in here to take you step by step into testing a claim. We cannot just read a claim and say you're right or you're wrong. That is not scientific. Now, in a scientific way, we have to go through the process. We have to go through the whole proceeding to prove a claim to be right or wrong. So we get that. But I want you to remember those things. You can have a left tail, you can have a right tail, or you can have a two tail, and again and again and again. I want to emphasize this. How you decide that? By looking at HA. Look at HA to decide. Don't look at H note. Okay? To decide if it's a left tail, right tail, or two tail. Now, we're going to try to introduce more things for you to understand here. Now, in the previous chapter, we talked about C, which is what we call the confidence level. So C stands for confidence level. We know that. So confidence level. There is something we're going to introduce now, is going to be called significance level. So what is it? The confidence. Let's go back in here to try to remind you of confidence level. When somebody says my confidence level is 95%, what it means? The confidence level 95% is that if we hire 100 people to do a study, every person is going to come up with a different result. But 95% of them will agree within the range I came up with. In other words, will be agreement with me. That is what we call the confidence level. And we want the confidence level to be very high, like 95%. We don't want it low to be 20%. Now, there is something called significance level. The significance level is the complement. So if the confidence level is 95%, the significance level will be 5%, because 95 and 5 will be 100. And what is the significance level? The significance level, by definition, is the probability of making type 1 error. So forget the word type 1 error, just focus on error for a minute, and later on we're going to discuss this more. Now remember, alpha is the probability of making an error, and the probability of making an error, we want the probability of making an error to be low. You know, you want somebody to be right a lot and wrong not much. So that is the reason why you want alpha to be low. And we'll talk more about this, but let me give you another example. What if the confidence level is 90? Remember, the lower the confidence, the higher the error. Now, if the confidence level goes to 85, the error is going to go to 15. So keep that in mind, that the low confidence, the high the error, or the significance level, we call that in this case. So later on, I'm going to talk about the type 1 error, type 2 error. But keep that in mind. Now, there is another thing I want to talk about, which is p-value. So there is something called p-value. So what is the p-value? The p-value is a probability. Now, like in court, remember, in the justice system, we start with this assumption that the accused is innocent. Same thing in here. We start with this assumption. We always assume H note to be true. We always assume H note to be true. Then we tell you, listen, go collect your data. So when you go collect your data, you're going to come up with numbers. From your numbers, we can calculate either the Z score or the T score, whichever we calculate. Now, every Z score or Z score comes with a probability. Based on the Z score, we can calculate a probability. So the p-value is the probability that others will agree with you and come up with the result as the results you provided. So in other words, the probability or the chance of others agreeing with you, assuming that H note is true. We'll understand this a little bit later. Now, let me go back to type 1 error, type 2 error. Now, again, we're going to define two types of error, which is the first one is type 1 error. Type 1 error is when we reject H note when true, when it's true. Now, let me give you an example. What if I tell you today is, and by the way, with what's going on, it's hard to remember the day. But what if I tell you today is Monday? So I'm true. I'm correct. I told you today is Monday, and today is Monday. I just checked my phone. It says Monday. What if one of you goes there and says, no, you're wrong? Now, if you tell me I am wrong while I'm right, you made an error. You rejected my true claim, which is today is Monday. So you made a mistake. Your mistake is called type 1 error. Now, let me give you a type 2 error. Type 2 error is to fail to reject H note when it is false. So in type 2, what if I tell you something wrong, like today is Friday, and you fail to reject? You said, oh yeah, so you made a type 2 error. Now, let's go back and try to make this more realistic into what we are talking about, which is statistics in here. One of the things we hear about and we are going through right now, and if you watch the news, you are oversaturated with this information, something about the coronavirus. Now, let me give you an example of a type 1 error and type 2 error. And I want you to tell me which type is more dangerous than another. So remember, when we make mistakes, some mistakes are less damaging than another. So I want you to tell me which type error. Again, we should not really make errors, but nobody is perfect. So let's give you this example. Somebody went and complained that they have headache, they have fever, whatever it is. They went and they were tested for the coronavirus. Now, they were told that they have the coronavirus, while in reality, they don't have the coronavirus. Okay, so they were told that they have the coronavirus. In other words, they are positive. While they are not positive, we call that false positive. That is bad. So this person who we tell that you have the coronavirus and they don't have it, they will gonna feel crabby, they're gonna feel weird, they're gonna be isolated, they're not gonna deal with their family for so many 14 days or more. So it's gonna be awful. So they did not have the virus. We told them they have the virus. We made a mistake, and they're going to deal with it. Let me give you the other example of an error. The other example of error, which is an error when somebody has the coronavirus, they go get tested, and they are told they don't have it. So it's called false negative. Okay. So what happens is they're going to get the coronavirus. They have the coronavirus. They go home. They celebrate. They have their friends and family and everybody, and then the family is infected with that virus. Now, the first type, which is type 1 error, is when we tell somebody, when somebody does not have the virus, when we tell them they have the virus. That is a type 1 error. Type 2 error, when somebody has the virus That's type 2 error. When they have the virus and we tell them they do not have the virus. That's called the type 2 error. So which one is more dangerous, type 1 or type 2?
Type 2.
Any other opinions? I'm not saying the ones who answer are wrong. I want you to understand the difference.
Type 2.
Type 2. I agree with you. Type 2 is more dangerous. Type 2 is more dangerous. Now, let me give you another example that is maybe ethical example, if you took ethics class or something like that. Now, reject H note when it's true. Now, you see something right when it's true. You see somebody standing in there and giving people, you know, these days, free lunches. Okay, so you stand in there, and what you do, instead of saying, this is the right thing to do, they are true already, what they are doing is a great thing, and you go in there and you reject them. You just tell them, don't do it. So you made a mistake, and that is a type 1 mistake. So it is bad that you're telling them not to do it, but you did it. Okay, that's type 1 error. Type 2 error is what? You see somebody who is passing something like rotten food or something like that. So you see somebody who's doing something false, wrong, doing something awful, and you stand in there and see them doing that awful thing, and you don't tell them to stop. That is a type 2 error. Type 2 error is a bad error. Okay? So we keep that in mind. So we talked about, as of now, we talked about the p-value, about type 1 error, type 2 error. We talked about the significance level. We talked about how to construct or the type of test. We call those testing: tail test, right tail test, two tail test. We talked about how to construct H note and HA by reading the problem. So hopefully that is going to give us a general idea of where we are heading. So now, any questions before I proceed? And that's probably all of the things I discussed right now is from section 7.1. Again, we are covering chapter 7, and that will cover homework 6 and test 6. So any questions from this information? Okay, so how do we test a claim? How do doctors deal with us when we go to be like we complain about some issue? Like I go to my doctor, I say, doctor, I have sore throat. So what my doctor will do? Now, my doctor has many ways to test the problem. One way to test the problem is my doctor will tell me, okay, we're going to take a swab and we'll look at there. Sometimes my doctor will say, listen, you know, maybe we should take, my doctor may look in my mouth, say, open your mouth, look in there and say, okay. So the doctor can look into your mouth. Sometimes they take a blood sample and test it. Sometimes they take a urine test, sometimes. But at the end of the day, all tests must lead to the same conclusion. Same thing in here. With this testing claim in here, we have options. And you don't have to use both, but we have options. One option is to deal with, compare a probability to a probability. You compare the p-value, you compare it to the alpha. Because notice the p-value is a probability and alpha is a probability. So we're going to compare the p-value to alpha. And the second way to do that is we're going to compare something called the test statistic. We're going to compare that to the critical value. So let's see what we can do in here. And let's see if we can work with those things with this example. Let me work with an example. By the way, you all know, and we all know how to find critical values from the previous chapter. There will be a small tweak in here about how finding the critical values. The good thing is, and the great thing is, StatCrunch can calculate for me the p-value. StatCrunch can calculate for me the test statistic, and StatCrunch can calculate for me the critical value. So as a result, the only thing that StatCrunch cannot calculate is alpha. And by the way, alpha must be given in every problem. So we're going to rely on StatCrunch heavily in here. So let's start with an example. And with this example, I'm going to show you how we work this. So with this example in here, let's assume that somebody made a claim, and the claim is the average age, in this case mean average is the same, the average age of victims of the COVID-19 is above, let's say, 50 years old. Somebody made this claim. Okay. Therefore, we hear this all the time. Young people don't care about it. It's very, you're not, it doesn't, when we start hearing about the COVID-19 or coronavirus, they were telling us young people are safe. It doesn't get to them, just older people. So in this case, I want you to stick with section 1. So this is, by the way, this problem in here from 7.2. In 7.2, we're going to assume population standard deviation to be given. Let's say that the population standard deviation is, let's say, 7. I'm faking those numbers, by the way. So you are interested in testing this claim. Is this really true, what they are telling us, that the average age, and we don't know who's telling us this, but the average age of victims of the COVID-19 is above 50? So what do you do in here? You say, okay, I'm going to try to answer this question. So to answer the question is, I don't go and say CNN said so, or so-and-so, or this hospital or that hospital. To do that, we have to go and collect data. So this is your response to this claim. Your response is to collect data. And remember, this, what we need to do is called random sample. You don't just ask or survey people in your neighborhood, Toledo, whatever. You have to do that all over the country, random sample. So this is what you did. In your survey, your sample included, let's say, 100 people. You surveyed 100 people who were infected with this virus. And from your sample, you found that the sample mean, the average age, to be, let's say, 54 years old. Okay. Now let's assume that alpha, that given to you to be 0.05. Notice that it is very dangerous to stop here and say, listen, the claim says it is above. Notice that here it says the claim says above 54, and my sample says, above 50, and my sample says 54. Look, the claim says above 50, and my sample said 54. 54 is above 50, then therefore the claim is right. This is very dangerous. Don't do it. I'll tell you why. The claim is about everybody. The claim is about mu. And your sample is about sample X bar. Now notice that your sample gave you 54. It is possible that Steve will go and do a survey and get 48. It's possible that Mary will go and get 65. So we know from sample to sample results may vary. So you cannot really respond to a claim about all by just using a sample. And when I say a sample, by looking at the result of the sample, what you need to do is you have to put this through a process. And this is the process we need to follow. Now, here I cannot make judgment unless I go down to the end of the problem and I get to the conclusion. And the conclusion is either the p-value versus alpha or the t-statistic versus the t-critical. So let's see how we do that. So the first thing is I need to calculate or generate H0 and HA. Both H0 and HA is going to be statements about a average or mean. So both of them is going to be mean problems. And notice in the claim, if you look at the claim here, it says the average lifetime is what? is above 50. Above 50 means greater than 50. So we put this into HA because it says greater than 50. And automatically the opposite of greater than is less than or equal, and we put 50. And when we try to fill in the claim, we write the claim in the second one. So this is how we write H note and HA. Any questions about this? Okay, so what's next? What is next is I need to draw a picture. In this picture, I know that this problem is, or I'm not going to answer. What do you think? Is this right tail or left tail or two tail?
Right tail.
Okay. How do we know it's right tail? Look in here at HA. If you look at HA, it has a greater. Greater means it's a right tail. So this is a right tail.
Yes.
Notice that this area here, this region here is what we call reject H note region. So this is the area where we reject H note in it. So anything falls into the right area there is going to be rejected. So this is my first step. My next step will be, I'm going to calculate, remember, I'm going to use, for this example, I'm going to use both methods just to show you. But when you do your homework, don't try to use both methods. Use one of the two. Okay, so let me show you the first method. How do we test the claim? Method 1. And again, you don't have to use both methods. Method 1, I'm going to use the test statistic versus the critical. By the way, because the mean is given in here, we're going to call it Z critical. Okay, or sigma's known. So let's first of all find the Z critical. How do you find Z critical? To find Z critical, you go through those steps. Stat, and you're going to go through calculators, and you're going to go through normal, and then the mean will be 0, and the standard deviation will be 1 again. And then finally, because this is a right test, when you go to the bottom in here, X will be, because it's right, is going to be greater or equal to equal. And in the last box in here, you're going to fill the alpha. So remember, alpha goes, oops, the screen goes. Alpha goes into the last box. In this case, our alpha in our problem, if you remember here, it is 0.05. So you're going to put 0.05. When you hit compute, the answer goes in there. So what is the Z critical? Let's see. Let's use StatCrunch and find the Z critical. I'm going to go through this problem as shown in here. To find the Z critical, I'm going to follow those steps. The first step is stat. Then I go to calculators and down to normal. Notice that I'm going to go in here into greater, because look at this. The way it is right now, the red is in the left. I want the red to the right, so I'm going to go right. Then after that, I'm going to put in there my critical confidence or significance level, sorry, which is in this case 0.05. Now, if I put 0.05 into the last box and hit compute, that's going to give me the critical value. What is my critical value? It is 1.644. It is 448 something. Let's stop at 3 places. And in the homework, you stop as requested. So this is my Z critical. So remember, I found my Z critical, and that is 1.644, whatever. So I found this. Now I need to find the T statistic. So, or test statistic, sorry, test statistic. How do I find the test statistic? To find test statistic, it depends on what you are dealing with. In this problem here, we know that sigma is known. Sigma is known, and we know it is a mean. So this is what we follow. We use stat, and we're going to use Z stats. Notice that later on in section 2, when sigma is not known, we don't use Z, we use T stats. That's the difference. Then after that, we're going to go to one sample. and we're going to go to with summary. And after we go through all of those steps, you're going to come to the page where it says fill your data. Fill the data. What do you need to fill in this case? You need to fill the mean. Remember, because you went in there and you did a survey. So what is the mean of your survey? What is the standard deviation from the population itself? Because sigma is known. What is the sample size? Then after that, what is the test that you have? So you're going to fill the data and you're going to fill the test. And you're going to hit compute. Let me show you. But before I show you, I need to scroll up because I need to show you all of this here because I need this. Okay, so this is what we do. We're going to close this. We're going to go to stat. We're going to go to ZStat. We're going to go to one sample with summary. And then the sample mean, notice that when you collected your data, you collected data and the sample mean was 54. So you're going to put the 54 in there. Let me move this around. We're going to put 54. And what is the standard deviation? Notice that the standard deviation given in my problem here is 7. So I'm going to put the 7 in there. Then I'm going to go to the sample size. Notice the sample size is 100 people. I surveyed 100 people. And I'm going to go down to the test, and I'm going to make sure my test is the same as in here. Notice that with StatCrunch, always, 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 the H note is equal. I cannot do anything about it. So that is fine, but you can do something about the bottom one, which is greater than. So you're going to put the HA to be greater than, and greater than who? 50. So the minute you type 50 in the top, 50 appears in the bottom. So as long as you match HA to our test and match the sample mean, standard deviation, size, hit compute, you're going to get what you're looking for. What is the Z-stat and what is the p-value? Look at this. The Z-stat in here and the p-value in there. So let me go back in here and try to fill this information in. So based on my calculations in here, the Z-stat, or by the way, it's called Z-stat, and I call it up there, I call it test statistic. Remember, test statistic is a general name. So if it's a Z test, it's called Z statistic, stat for statistic. Now, if it's a T test, it's going to be T statistic. If it is a proportion, it's going to be, as again, it's a Z statistic. So the Z statistic that I get is 5.71. Okay. So now let me show you method 1, what we do. In method 1, this is what we do. Here's our picture. We know that this is the right test. We talked about this early. We know that the critical one is 1.645. That is the Z critical. And notice that the Z critical in your book sometimes is called Z0. Z critical, Z0 is the same thing. Notice that the value that we got here, which is this, does not fall here. It's going to fall somewhere in there. Because we know that 5.71 falls above 1.64. Because the 5.71 fell above 1.64, automatically we're going to say this. We're going to say reject H note. How come? Because the Z-stat fell into the rejection region. Like when you go to your doctor. Now, acceptable high blood pressure. Now, if your blood pressure after testing you is above that, in other words, you fall into the red region, the red zone, then automatically the doctor is going to reject the claim that you are healthy. Because we said assume H note to be true. We assume H note to be okay. We are rejecting H note to be okay. In this case, we're going to reject H note. Let me go back in here and bring my statement there. I'm going to put it down here because I need to comment now. So I'm going to, this is my statement. I'm just going to put it there just to show you. Notice that based on my statement, I decided to reject H note. Now, if I reject H note, automatically the HA is the opposite. You fail to reject HA. And notice that to reject HA is the same as fail to rejecting the claim. So what are we saying in here? We are saying in here we're going to fail to reject. We're going to fail to reject the claim. Remember, rejecting H note is not rejecting HA, and HA happened to be the claim, so we are failing to reject the claim. So what is the claim? We're going to go back and say, okay, what is the claim? Here is the claim. The claim made by this gentleman is that the average age of victims of the COVID-19 is above 50. So we're going to tell this gentleman, listen, in other words, your claim is going to, based on the evidence we have, the average is confirms with what you have. So it is above 50. Okay, so this is how we test the claim using method number 1. Now, I don't like method number 1. Let me show you the second method that we can use, which is we're going to call method 2. So we have method 2. Method 2 is to compare the p-value to alpha. Notice that when I followed the steps above here, when I followed those steps, let me point to those. When I follow those steps in here, I got what I call the Z statistic. Let me go back to StatCrunch. I did the steps. I got this Z statistic. But I also get a p-value. At the time you get the Z statistic, you get the p-value automatically. So what is my p-value? The p-value, notice that there is a symbol, it says less than, and it says 0.0001. So let me show you what this is. Now, my p-value is less than 0.0001. In other words, my p-value is not 0.001, it's way smaller than that. In other words, my p-value is too small. And my alpha in the problem is 0.05. So what do I do? What do I do if the p-value is less than alpha? This is the test that we will use all the time. And the test talks like, or states the following. The test says, if the p-value is less than alpha or equal to alpha even, reject H naught. If the p-value is bigger than alpha, fail to reject H naught. So this test is good for all problems, not just this one. So we look at the problem and we say, okay, if the p-value is less than alpha, in this case, look at this, the p-value is less than alpha. If the p-value is less than alpha, what do we do? Reject H naught. So in this case, we're going to reject H naught. And that is exactly the same decision we took earlier. Remember, with the first test, we rejected H naught, and here we're going to reject H naught also. So we're going to reject H naught either way. So we are rejecting H naught. But notice that in the previous test, it was longer. And in here, it's very fast. In the previous one, I have to find the Z critical, which is a process by itself, and I have to find the p-value, which is a process by itself. Here, I can find that just one process very fast, and I can run the test. I can get to my conclusion. Now, how come if the p-value is less than alpha, we reject? Remember, alpha is the error, and the p-value is the probability of success. So if your probability of success is way smaller than the error, in other words, the error is bigger than success, then we're going to reject. And if the error is smaller than success, then we're going to fail to reject. So that is the easy way to think about it. Now, any questions?
How did you get the p-values number?
Okay.
0.001.
Okay, I followed the same steps to find the Z statistic. It's the same thing. Let me repeat those steps. And let me go from the top down in here. So here's the steps how to find the p-value. You go to stat, Z stat, one sample with summary. And then from the problem here that we have the sample mean of 54. So we just put the 54 in there. And the sample standard deviation is 7. We put 7. The sample size is 100. We put 100. And the test says 50. And it says greater than 50 in the bottom. So when you do all of that, when you hit compute, notice two things will appear: the Z statistic and the p-value.
Okay.
So both of them will appear together.
Okay. Thank you.
You're welcome. Anything else?
And you're okay to always use the method 2 on all these problems?
Yeah.
Like we don't have to use
Yeah.
method 1 at all?
You don't have to, but here's the problem. This is a class. So in a class, you're stuck with the question. So some questions in the homework, they ask you to find the Z critical. We can live without it. But they want to know, do you know how to find the Z critical? So you are stuck and you have to use it. They ask you to find the Z statistic. So you are stuck, you have to find it. Now, if at the end of the question, if they ask you what to do, even though let's say that you use the Z statistic and the Z critical, you don't have to use that. Look at the p-value on alpha. Okay. Now, if you are doing this on your own, like in some problems, you know, they tell you, they don't tell you anything. They tell you, okay, what should we do? So you can use the p-value on alpha. But in the homework, you're stuck with what they ask you to do. You understand what I'm saying?
Yeah.
Okay. So sadly, in a classroom, sometimes we teach more than what we need. So in real life, by the way, in the last maybe 5, 6, 7 years, in all statistics textbooks, they are moving slowly into the p-value, and they are even ignoring completely the term critical values and test statistics. They're not using it anymore in new published books because the p-value is the way to go. Because this requires technology, and again, if you ever attend or listen to scientific presentation, or you read about any research, whatever, they always mention the p-value. They never ever mention anything but the p-value. So the p-value is mentioned more than you can imagine. And you know, it's sometimes many people sitting in there probably don't know what they are talking about. I mean, the people in the audience were not talking about, but it is used a lot. So the p-value is the way to go.
Okay. So after you get that Z critical value in method 1, where again do you find the Z stat?
It's the same window here. Look, when you do the, here's the Z stat. When you follow the steps, the minute you find the p-value, that's the reason why I prefer this, because if you follow the steps, it's going to give you both the Z stat and the p-value at the same time.
Okay.
So if you like to find the Z stat, it will give you the p-value. If you like to find the p-value, it will give you the Z stat. So you're going to hit the two at the same time.
Okay. Thank you.
You're welcome. Anybody else? And I'd just like to mention something in here. I'm going to make sure, talk to me, because I'm not going to be able to see your comments in here. But if you go to your class, do you see my screen right now, Blackboard, everybody?
Yes.
Yeah. Now, if you go to Blackboard and click on WUP meetings, and after that, click on the 3 lines in there, which is the menu, and you go down to where it says recordings. And I'm sure many of you already know that. Now, I want you to know this, that I already did homework 6, questions 1 to 19. So almost 2/3 of the homework. And don't pay attention to homework 5 anymore. Look at homework 6. Homework 6, video 1, recording 1, recording 2, recording 3, recording 4, recording 5. There are 5 recordings. Those 5 recordings about the homework. So you can view them. If you go to the second page, there are chapter 7 and 7. I'm pointing to those two. There are 2 recordings from chapter 7. I did those 2 recordings on my own, so nobody was around. So I talked about in general, maybe I presented different examples, different things, but you can look at those 2 recordings also. Maybe later on today or tomorrow or so on, I'll go ahead and remove the recordings from chapter 6 or homework 5, because I was told that Blackboard is reaching its limit with recordings, and we are afraid that is going to crash. So I'm going to try to remove most of those videos. And by the way, we don't need them anymore, because in chapter 7, I just want you to focus on chapter 7. I don't want you to go back to chapter 6 and so on. So you're not going to benefit from those videos on your course. Is that okay? But remember, there are many videos for you right now to go and watch. So I hope you take advantage of that. Any other questions?
Thank you.
You're welcome. Anybody else likes to say something? Okay. So I think because for the sake of making the video short, because of loading and whatever it is, I'm going to stop the recording now, just to help us avoid this mistake, this